Hi students, what I'm going to be looking at today is the technique of titration. Okay, so titration, you recall, is where you have two solutions and you react known volumes of those solutions together, and you can use that technique to determine the concentration of one of them if you don't know it. First thing I'm going to look at here is important pieces of equipment in a titration. The first most important piece of equipment is this one here, known as a burette. Okay, a burette is a long tube here with a tap at the bottom of the tube here, and you can turn on that tap to release solution into a container below. The thing about a burette is that when it is full of a solution, the markings on a burette start at 0 and go down to 50 because it is designed to be releasing a solution. Okay, so you fill it up to the top here, and then as you release the solution, you can determine from the scale here the volume that you released. Okay, the burette fits into your burette clamp like this, which holds it very steadily like that. Okay. The other piece of equipment that's very, very important is this piece of equipment here, known as a pipette, or more accurately, a volumetric pipette. A volumetric pipette, a very important piece of equipment here. A volumetric pipette like this one only has one marking on it, and that is up here. Okay? It holds, or it releases exactly the volume that is written on it. So this is a 20 ml pipette. Okay, and so when I fill up this with a solution, when I release that solution into a container underneath here, it will release exactly 20 mils. It's extremely accurate. It contains a very thin glass tube here that gets bigger in the middle to hold the solution. And the glass is extremely thin. You'll notice I don't hold it in the middle, I hold it above and below what we call the bulb, because the glass there is so thin that if I was to hold my hand on that part of it, I will warm up that glass, it will expand, and it will change the volume of the equipment, and I don't want that. Okay, so that's a pipette. Now, a pipette is a difficult piece of equipment to get solution into. You can't very well take one of these bottles and pour it into a pipette. It just doesn't work. So what we use is this piece of equipment known as a pipette filler. Or, in the Alexander classroom, we call it a pumpy thing. And I say that because every year that I've taught this, I call these pipette fillers, and students forget the name, and they come up to me and they say, "Can I have the pumpy thing?" So we call it a pumpy thing, okay? Now, the pumpy thing has 3 valves on it, okay? And they are designated A, E, and S, okay? And if I show you what those 3 valves are all about, basically, the pumpy thing is an artificial mouth. We used to, when I was at university, we used to put liquid into here like a straw by literally sucking it in like a straw. That's a little bit dangerous because you can suck that liquid directly into your mouth, and yes, I know that from experience, and it's not pleasant. So what we use is we use an artificial mouth here, and we attach that to our pipette, and it holds onto it very, very well. And what we do is with the 3 valves is that A is for air, and when we squeeze that valve, the air is removed from it. S is for suck, and when we squeeze that valve, it draws air in up through the tube here, so it's like sucking it in. And then E for expel or exit. When I squeeze that valve, it allows air to flow through and it releases the liquid. So that is our pipette, which is the other piece of equipment we're going to use. The final pieces of equipment we have here are simply a conical flask. This is a 250 conical flask. You can use a 150 conical flask. You generally don't use a beaker for this sort of thing because when you are doing the reaction, you are swirling the solution. Beakers are difficult to swirl because the solution can spill, but flasks are very easy to swirl, so we generally use a conical flask. The conical flask sits underneath the burette, and we release the solution into it. The final piece of equipment that I have here is just a white ceramic tile. The purpose of the ceramic tile is we are going to be using what we have, an acid-base indicator, which changes colour during the reaction. It's quite difficult to see that colour change on the bench top here, so what I do is I have a white tile, because when my flask is sitting on that white tile, I can more easily see a colour change. So that just sits there underneath my burette. Okay, so let's go through some of the things that I need to do in order to do a titration. I have 3 solutions here. Okay, this is a very simple acid-base titration I'm doing, so the reaction is between an acid and a base. So first thing I have here is some sodium hydroxide solution. The second solution I have here is hydrochloric acid solution. And the third solution is my indicator. Now this indicator is the one with the impossible to pronounce name called phenolphthalein. Phenolphthalein is a very, very good indicator because the 2 colours it has in acid and base are, as you can see from this, colourless when it's in an acid, and it turns a bright pink colour when it's in a base. And that pink colour, I'll show you what that looks like, looks a bit like this. So, I'm going to be using these 3 solutions in my titration. The first thing I need to do is I need to pipette one of the solutions into my flask. It doesn't actually matter which one I put into the flask. Okay, so I'm choosing here to put the acid into my flask, which is this solution here. You shouldn't generally pipette directly out of the stock bottle because I don't want to contaminate that with anything that might be on my pipette. So what I've got here is just a normal beaker that I'm going to use to do this pipetting process. So I'm going to add some of this hydrochloric acid solution to the beaker, like that. I don't need to add an enormous amount, just enough for my pipette, which is 20 mils. So I put in there around 50 or 60 mils, and that's plenty for what I'm doing. I then get my pipette with my pumpy thing attached. Okay, I squeeze the air out of it like that, and I simply dip that into the solution here, and I draw the liquid up into it by pressing the S button. And you can see the liquid is rising up there. Okay, and I just gently squeeze it until the liquid moves above the mark here. I pull it out of the solution, and I just hold it at eye level so I can see it clearly. I just carefully squeeze the E button until the meniscus is right on the line like that. I then take it to my conical flask, and I hold it against the edge of the side of the flask, which is important, and then press the button again to release the liquid. And that will just release it completely into my conical flask. Like that. Done. Okay? I take my pipette, I carefully put it over on the bench here. One of the advantages of the pumpy thing is that it stops the pipette from rolling, because you don't want to break it. So that's my solution. I'm going to take this solution, and I'm just going to label this beaker, because my solutions are all colourless, so I'm going to label this HCl so I know which one it was, and just place that over there, like that. So there's my HCl solution ready to go. I'll just put that over there. The next thing I need to do is I need to fill up my burette. Importantly, I close the tap first, okay, and I get my sodium hydroxide solution. And once again, I'm not going to pour it directly from here. It's difficult, so I have a second beaker here that I'm going to put some sodium hydroxide into. Now, my burette volume is about 50 mils, so I'm going to put in enough here so that I can fill that up completely, like that. Once again, I will label this beaker so I know which solution is in here. NaOH, like that. Okay? Now I'm going to fill it up. Now, you can use a funnel in the top of your burette here, and that's usually the safest way to do it, to pour the liquid in. One thing that people do with a funnel is they pour too much in and it all overflows. I'm going to try not to do that when I'm demonstrating a technique. So I pour in my sodium hydroxide into my burette. And I need to fill it up above the markings at the top. So I'm going to fill it up about that much there. Okay? Put that beaker out of the way. Importantly, always remove the funnel, okay, from your burette before you titrate. I've gone above the mark up here, and the reason for that is that there is a volume underneath the tap here which has no solution in it. And because when I turn on the tap, I'm going to be measuring what has gone out of the tap, I need to fill up that volume. We call that filling the tip of your burette. So I have here a third beaker that I'm going to be putting underneath that, okay? And all I'm going to do now is I'm going to turn on the tap quite strongly here to release liquid into the tip like that, then turn it off, and now I look at the mark up here, and I just turn on the tap and carefully drop this down until the liquid flowing. There we go. Just drop it down until the meniscus sits on 0 of my burette, like that. Done. Okay, now I'm ready to titrate. So I take the beaker from here, just tap it to the edge there, because sometimes there's a drop left on the tip of the burette, and I'll just put that beaker over there. First thing I need to do here is I need to remember to add my indicator to my solution. Now remember, this indicator, phenolphthalein, is colourless in acid solution, so I'm not going to see anything in here. And that's often a problem. So 3 drops of that. That's often a problem with an indicator because you forget that you put it in. Okay, so I just need to remember, yes, I've added my indicator. I'm now ready to titrate. I'm just going to raise up my burette a little bit here so that I can fit my flask underneath it. You should always have the tip of the burette below the level of the flask. Okay, it just makes sure you don't lose any solution. Now the technique now is, my burette is at 0 here, and I'm going to be adding solution until my indicator changes colour. I don't know where that's going to be, okay? But you start to see a colour change during the titration. One important thing is that you swirl constantly while you are titrating. So turn my tap on here and begin the flow of solution. I see a very sort of faint pink appear, okay, and then the solution reacts and it disappears again. So I'm just going to keep on going here, swirling the whole time. You never let a titration just run. You always are swirling the flask, okay? It's not a static activity. You've got to be doing something the whole time. So as I go with this, the colour starts to, you get a pink, and you're waiting for the pink to persist for a little bit longer, okay? So I don't actually have to look at the scale there. I have to focus on the flask because that's where the colour change is happening. Now, just turn that off because I could see that I was very, very close to the colour change because the pink colour was just hanging around just a little bit. Okay, so just add slowly. So I've slowed down the rate that I'm adding my solution now. I'm actually adding it sort of fairly slow, almost drop-wise. Don't know whether you can see that. It's sort of just 1 drop every second or so being added. Okay, so very, very slow rate of addition because I can see that the colour change is getting very, very close to happening. Very close now, and I think, oh, very close. Maybe a tiny bit more. Let's try to add 1 drop at a time now. I'm actually turning on and off the burette and adding a single drop of solution each time. Probably see there the colour appearing and disappearing. I am extremely close. I reckon a single drop. So this is where your technique comes in. And you try to add 1 single drop because 1 drop will do exactly that. So that's the colour change there. That was a single drop to that colour change. And that is the end of my titration. I then take a reading off the burette, and that will give me the volume of solution that I have added. So the volume on the burette there, it's between 32 and 33. Okay, so it's over 32 but less than 33. It's between 0.7 and 0.8, so I can take that reading as 32.75.